In this video, we have the integral of arctangent of x, same thing as inverse tangent, over x squared. So for this type of integral, I usually look at a u substitution or integration by parts. And I decided to do integration by parts. I'm going to let the u in that formula equal to the arctangent of x because I can easily compute the derivative of that. And then the other expression, 1 over x squared dx, that's the same thing as x to the negative 2. I'm going to evaluate that integral of x to the negative 2. So let's look at the substitutions here. There's your formula. The integral of u dv is always equal to the product of u and v. We select the u to be something we can differentiate, and the v, or dv, something we can integrate. And then we find the v, and then the product of those two is the first part of the answer. And then we have minus the integral of whatever we get for v du. And we're hoping this integral that we get here in the formula is easy to integrate. So this will be equal the product of u and v. So that'll be arctan of x multiplied by v. That's x to the negative 1 minus x to the negative 1. So I'm going to put that in the bottom here. X to the negative 1, break it down, becomes an x here. And I put the minus sign in front here. And then it's minus the integral of v, which is minus x to the negative 1, times the du. So this is going to be multiplied then by 1 over x squared plus 1. That's dx. But then we write this again, minus arctan of x over, the x will be down here, the negative there. And then this will be a minus here. Got a double negative there, so that'll be a plus here. Take this x to the bottom, so this is going to be a 1 over x times x squared plus 1. And this is dx here. Now to finish the problem, we just have to integrate this. So we got 1 over x and multiply by x squared plus 1. So it's a rational expression. So we look at partial fractions here. So let me take this out over here. It's going to be 1 over x. So I'm going to try partial fractions. And this is not too bad here. We have one linear factor, not repeated, and one irreducible quadratic, not repeated. So I can write this over the constants. First one will be a over the linear factor x plus, then it'll be bx plus c over the irreducible quadratic. Multiply through by the LCD, which is x, and x squared plus 1. So this will give me a 1 over here. This will equal to, and then this will be a. X cancels, so I get x squared plus 1, multiplying the a. And then for the second expression, the bx plus c here, over x squared plus 1, the x squared plus 1 cancels, and x multiplies this. So this would be bx squared plus c. So again, this would be a 1. Let's put our like terms together here. So we got x squared, ax squared plus bx squared. So this would be, factor out the x squared. So this would be a plus b multiplied by the x squared. Then we got a times 1, that's a. And then the c was multiplied also by x here. This was bx, and then plus cx. This one came over here. So now we just equate the coefficients. We have an x squared here on the right side, but we don't have an x squared on the right side. So that means the coefficient on the left side is 0, which means that a plus b has to equal to 0. Now the constant term on the left side is 1. And over here on the right side, the constant term would be a. So that would tell me that a has to be 1. Then we have c multiplying the x, so that's the coefficient of x. On the right side, there's no x on the left side, so that means the coefficient there is 0, which tells me that c has to be 0. And we know a is 1 here. 1 plus b is 0, so that means b has to be negative 1. So we come down here then, and this is going to be arctan. Go right there with the capital, that's okay. Arctan of x. Still got the minus here, and this is over x. This will be a plus then. And that's going to be the integral. And this partial decomposition for this rational function is over here then. We know the a is equal to 1 here. C goes to 0. And the b is negative 1. So this one simplifies to a is 1, so this will be 1 over x plus. So for this next one, c is 0, b is negative 1, so I get negative 1 x over x squared plus 1 dx. So we just have to finish this integration here. So it's still got minus arctan of x over x. And integral of 1 over n dx, that's your dx over x, or if you want du over u, that's the natural log of absolute x. And then for the second integral, this is now the integral of minus 1x or minus x over x squared plus 1 dx. Now for that one, you could use another substitution. Say let t equal to x squared plus 1, so your dt would equal to 2x dx divided by 2 here. This would cancel d2, so dx would be replaced by d2. You'd have the 1/2 in front, and it would actually be dt over t. So it's the same thing as for the first part. It's just a natural log. So this would just be minus, we're going to have the 1/2 from here, dt over 2, so this would be 1/2 of ln. And because it's x squared plus 1, we don't need absolute value, so we can just put it parentheses x squared plus 1 plus c. So your final answer then is minus arctangent of x over x plus the natural log of absolute x minus 1/2 natural log of x squared plus 1 plus c. The other thing I want to remind you is, remember you can put these two together. You have a difference of logs here. So you can put this 1/2 here for this one and make this the square root of x. Just to the 1/2 will be a square root. And because you have a difference of logs, you can write it as a log of a fraction. So you could rewrite that if you want ln of absolute x over the square root of x squared plus 1. For me, this is fine the way it is. But there's some instructors that want it simplified as much as possible and put those together. Again, the exponent makes that a square root. The difference here makes that the log of a fraction. Thanks for watching. We'll see you next time.